Hello, welcome back to Every Problem. This is Stewart Calculus section 2.3, problem number 23. If you saw any of the last videos with problem 11 and 21, we saw two methods of finding these limits. One method was factoring. The other was multiplying by the conjugate. And there's one other thing that we can do in this problem. And if you're ever having a hard time finding these limits, just understand that there's usually a few different things you can try for some of these limits. There's factoring a polynomial, as I've written there, multiplying by the conjugate with square roots if we have fractions, or if we have these kind of more sophisticated fractions here, we've got like 1 over x minus 1 over 3 all over x minus 3. What I like to do is immediately I like to try to make this a little bit more simple of a fraction. And so here's what we're going to do. Well, first we'll rewrite it all. 1 over x minus 1 over 3 all over x minus 3. And we are going to multiply the top and bottom by 3x because I really just want a nice simple numerator. I don't want these double fractions on the numerator. So when we do that, we have to multiply this term by 3x, and in this case the x's cancel out. So we just get 3. Now we have to multiply this term by 3x. And in that case, the 3's cancel out. So we have 3 minus x all over x minus 3 times 3x. Okay, I'll write this third technique right up here as simplifying. That's not quite right. There we are. Well, I don't quite know what specific term to use here, but I'll just call it like double-decker fractions. That's just when we have fractions over fractions. I'm sure someone could leave a more proper name for that, but we'll just do that for now. Okay, so those are our 3 different things that we can do. And now we're left with this. And here's the last thing, the 4th thing that we can do, which is kind of a subcategory of factoring. We have 3 minus x over x minus 3 times 3x. And we need to remember that x is approaching 3. So we are still going to get this 0 over 0 problem, and you do not want that. That's not what we are trying to do right now, finding limits. Now, this, until I learned about this, it was very frustrating trying to figure out how am I possibly supposed to make sense of this? Well, here's what we can do. We can take this 3 minus x here, and we are going to factor out, and so first I think, well, wait a minute, how could you possibly factor something out of that? Well, factor out -1. Okay, so, well, what happens if we do that? If we pull out a -1, that means the 3 has to turn into a -3, and this negative x has to turn into a positive x. Okay, well, wait a minute. If we do a little bit of rearranging, then we have -1 times x minus 3, and there's our solution. Now we have something to cancel out this denominator with. So let's rewrite this now. Now we have -1 times x minus 3 all over x minus 3 times 3x. Okay, so now we can cancel out these numerator and denominators there. And now we're left with negative 1 over 3x as x approaches 3. And now x can approach 3 without giving us any problems, right? We won't run into this 0 over 0 problem anymore. So this is wonderful. Now we can do negative 1 over 3 times 3, and that will give us negative 1/9. And that is going to be our answer for number 23. So I hope that helped. And I'll write here, I'll write even negative 1 in factoring, because that's something that we can sometimes forget about. You can factor out a negative number, and that can help switch around your fraction or your number, whatever it is that you need to have some sort of cancellation. The whole idea with these limits is they usually involve fractions for limits that give you problems, because the limits that give you problems tend to have zeros in the denominator. You need to find some way to get that zero out. Usually the way that that zero can get out is through a cancellation, and that cancellation can come about simplifying your giant fractions. You can factor and cancel. You can even factor out a negative 1, or you can multiply everything by the conjugate if you happen to have square roots in your fractions. And that's everything I've got for problem 23. If you have any questions, let me know, and I'll try to get back to you in some reasonable time. So thank you, and good luck with everything.